right, Mom. I'm going to go over with concrete numbers how this would work based on the numbers the New York Times gave. So let's pretend that we had a population that was sized, hold on. Let me start out that was sized 100,000 people. And what we know about that is that there's a 5% infection rate. So 5% are infected, meaning those that are infected and recover, we're going to expect to develop the antibodies. So if we're omniscient, out of 100,000 people, we're going to expect that, 5,000, which is 5% of 100,000, are truly infected. Okay? And that means that 95,000 are not infected and they don't develop the antibodies. Okay, so now let's pretend all 100,000 people get tested. And the other information they gave us was that the tests are 90% accurate. And so all that means is that whether you're positive or negative, if you get tested, there's a 90% chance that your result is accurate, meaning there's a 10% chance that it's not accurate. So what that means is that for the 5,000 that are infected, they're all going to go get tested, and 90% of them are going to receive the correct result, which if they are infected, we're going to call that a true positive result, because if the test was perfect, all 5,000 of these people would receive the result that they are infected. However, it's only 90% accurate. So 90% of them are going to receive a true positive result, and 90% of 5,000 is 4,500. All right, now, that means that 10% of these people, 10% are going to receive a false negative result, meaning they truly are infected, but they're going to receive a negative result falsely. And so that's going to be 500 of them, right? Now let's go over to the other side. These not infected people take a test, and all 95,000 of them should receive a negative result if the test was 100% accurate. However, it's only 90% accurate. So 90% of them are going to receive a true negative result because they are not infected. They should receive a negative result. So 90% of 95,000 is 85,500. All right, and then the other 10%, even though they should receive a negative result, are not going to receive a negative result. They're going to receive a false positive, right? Because they're not infected, but they're going to get a positive result. So 10% of 95,000 is 9,500. All right, and so now let's look at the probability that they're talking about. So what I want to know is, what's the probability? So this is called probability notation. So what's the probability that a person is positive given that they test positive? Okay, so that's the probability that we're looking for. Now, this is called a conditional probability because we're given a condition that narrows the population we're looking for. We're given that they test positive. So we only want to look at the people who test positive. So at the bottom of my tree diagram, we can focus on two categories. The false positives, which is 9,500 people, and the true positives, which is 4,500 people. So the total in our population that we're looking at is 9,500 plus 4,500. So 9,500 plus 4,500 is 14,000. So to calculate this probability, we're only going to be looking at this out of a population of 14,000. All right, so what we're looking for is the probability that they actually are positive, right? Okay, so how many out of those 14,000 were truly positive? Well, only this 4,500. So that's going to go in our numerator here, right? That's the way we calculate a probability, is we look at total possible number of outcomes. So total possible number of positive results were 14,000. And then we look at the number of successes. And successes in this case we're defining as true positives, and that's the 4,500, right? So similar to, we know that probability of flipping a fair coin and getting heads is 1 out of 2, because there is one head out of 2 total outcomes. All right, and so if we actually divide this out, it comes out to about 0.32, or 32%. So here's what that's saying. If you go get an antibody test and you test positive, there's still only a 32% chance that you are positive, right? Which means the complement of that is that there is a 68% chance that you are not positive, or that you don't have the antibodies. The time's rounded up to about 70% to sensationalize, but that's the math of it. So let me know if this made sense to you.